Ladies and gentlemen, we ask that you please take your seats at this time as the program will begin momentarily.
To do research, you need research questions. Research questions are questions that must be answered during the project. These answers should generate information that is useful and necessary to accomplish your research objective. It is important to realize that research questions are generally not the questions posed by the client of your research. Rather, they are the questions you, as a researcher, develop to shape the design of your research. Research questions are iterative in nature and not static. They will develop and change during your research design when you're developing your theoretical model and your conceptual framework. Typically, research questions are questions about the why, the what, the how, and the when. And as you can see, these are open questions. Questions that just have closed answers, such as yes and no, are generally not good research questions. A well-formulated research question meets the following two requirements. Firstly, it must meet the efficiency requirement. The question should refer to the degree of knowledge required and the degree to which knowledge contributes to the research objective. Secondly, it must have a steering function. That is, it must indicate the type of knowledge required and help to decide what material data needs to be gathered during the project. There are different ways to develop research questions. Generally, you first develop a preliminary research question from the main issue that will be investigated and the key concept the work is focused on. Then, after you develop your theoretical model and conceptual framework, you finalize your main research question and start to develop sub-questions. Remember though, that you can never have one sub-question. When developing your questions, start on a qualitative descriptive level and where appropriate develop this to a question that may need to be answered using quantitative numerical evidence. For each question, ensure you develop what the main drivers are in your research and focus on knowledge capture at an appropriate level, relative to the body of scientific knowledge. Next to checking if your research methods meet the requirements of efficiency and the presence of a steering function, it is also worthwhile to check the formulation of your research question against the SMART principle. SMART is an acronym for specific, measurable, achievable, realistic, and time constrained. This avoids formulating research questions that are too vague, too wide, or impossible to achieve given available time and resources. For large multi-year or multifaceted research projects, it may be necessary to divide your research into semi-independent work packages, each with their own objective and own main research question and their own set of sub-research questions. What does this all mean in practice? Let me give you an example. What is the effect of manufacturing aluminum sheets using a 3D printer on the failure load of aluminum? This question is incomplete. It alerts to an effect, but effect how? Compared to failure load of what other manufacturing load? And, importantly, which type of failure? Due to fatigue, due to axial, buckling, or compression load? Better will be, what is the effect of manufacturing aluminum sheets using a 3D printer on the actual failure load of aluminum compared to sheets manufactured by rolling?